Good afternoon, and thank you for joining today's webinar from Spec Innovations using Innoslate for model-based systems engineering. My name is Sarah Craig, and I will be the moderator for today's webinar. Let's go over some quick housekeeping before we get started. For those of you who may not be aware, Spec Innovations provides systems engineering services and solutions to the aerospace, defense, and intelligence communities. Our flagship software, Innoslate, provides users with an all-in-one systems engineering software solution with requirements management, analytics, modeling, simulation, and analysis of alternative tools. We help organizations securely collaborate on critical projects throughout the product or systems lifecycle. During the presentation, feel free to send us questions using the panel on the right, and we will get them answered in the question and answer part of the webinar. The webinar is going to be recorded, and we will make it available to you after the live presentation, so be sure to keep an eye on it in your inbox. Now, I would like to introduce you to our presenter, Dr. Steve Dam. Today, he'll be showing you through the process of using Innoslate's modeling capabilities while applying a MBSE methodology. Dr. Dam is the president and founder of Spec Innovations. He has been involved with research experiments, operations analysis, software development, systems engineering, and training for more than 40 years. Dr. Dam participated in the development of C4ISR Architecture Framework and DoD Architecture Framework, DODAF. He also has received an Expert Systems Engineering Professional ESEP certification from INCOSE. He currently is applying system engineering techniques to various DoD, DOE, and commercial projects. And now I will hand over the controls to Dr. Dam, and we will get started.
Probably easier if my microphone's on. Thanks, Sarah. Let's just jump into today's presentation. So a little bit of an overview. We're going to talk a little about what we mean by model-based systems engineering, because I think there's a lot of confusion as to exactly what that means. Why we have a question about how we're doing model-based systems engineering, give you a little bit of history, show you some of the things that we think are missing, talk a little bit about SysML, and talk about some of the technology improvements and things like we're looking at, and talk about how we envision the future and how we think we're building towards that future today. So first of all, what do we mean by model-based systems engineering? So first of all, we have to go back to saying, well, what's a model? And of course, a model is just a representation of reality. It's an abstraction. It doesn't contain all the information about the reality. It contains as much as we can put in there. Unfortunately, a lot of people think models are complete and models are accurate. Models are, the definitive word in things. They aren't. They're just a mechanism we use to help understand things better and communicate things better. So, models are great, but remember that what George Box said, essentially all models are wrong, some models are useful. And that's an important thing to always keep in mind. So the purpose of the modeling is to help us derive the functional requirements, the performance requirements of the system, and then verify and validate that those requirements have been met and support them throughout the life cycle through that process. MBSE, according to INCOSE, of course, they defined it as kind of their term. And you've probably all read this definition, but I'll read it to you anyway. So MBSE is the formalized application of modeling to support system requirements, design, analysis, verification, validation, beginning in the conceptual phase, design phase, continuing that throughout the development and later lifecycle. Well, of course, that says basically it covers the entire lifecycle. Great, that's good. Formalized application of modeling, okay. I think the first time I drew a flow chart, that was using a template. That was a formalized application of modeling. So I don't think that's really what we mean. So clearly, by this definition, MBSE has been around for a long time. We just called it different things in the past. But so what does this really mean to us? What are we really going to do with this, and how are we going to do something more with MBSE and make it more something different and valuable? So first of all, we think one critical thing about MBSE is it should support concordance. Concordance is where you're capturing information about the system. And that information, that piece of data, is then represented in many different ways and seen maybe in different diagrams and different viewpoints, different aspects of it. And you're going to derive information from that as well. But fundamentally, that needs to make sure that if you have an instance of it, it is reflected exactly everywhere else. There's always one of the problems of we have to deal with is the configuration management of the data, making sure we're seeing the same thing in the same way. So it's important. This is why the non-model based, the document-based approach is a problem. Because if you do a drawing and you use an object in that drawing, you need to reuse the object in another drawing. Well, if you don't have it as an object database behind it, then you're really in trouble. But if you have to manually put it there too, you're in trouble, okay? Because you're the one who has to do all the configuration management. So the tools that are behind model-based systems engineering need to do that configuration management for us. The DoD digital engineering strategy is starting to call this idea the single source of truth. Their idea is that you have it doesn't mean it's in only one database, okay? It means it could be in multiple databases, but there's one source that's the definitive source for that piece of information. And that's what we're trying to get to and work towards. So I think that makes good sense, and that's certainly something we support. So from the models, the goal to be generated by all the products needed in design and document the system throughout the life cycle. So remember that we're not just building this model for model's sake. We are trying to create the information base to go through the entire life cycle process, depending on, and it's different for different organizations. They have different things and different levels or difficulty of the project that you're working in. And so you have to generate, but fundamentally, when you boil it down, simply as you're coming down the V in the life cycle, you're creating the specifications, right, to procure the system, right? And so that ultimately becomes a legal document of some kind. And so I think if we think that the lawyers are going to accept models as a legal entity, a legal item by itself, I think we're kidding ourselves. So we still need documents, we still need models, and we want models to help drive the documentation and creation of documentation. So it's an and, it's not an or. These are not separate things. We want to show the information and work with the information as visually as we can, because a lot of people assimilate the information visually, but ultimately we have to craft the documentation too. Okay, so many people have been pushing the idea of the systems modeling language, SysML, as the basis for MBSE. A lot of people are using it, and that's fine. It was a very interesting language, and we'll talk about some of the background of that. But really, is SysML the future of systems engineering? And the reason I asked that question is I heard that question actually asked at a systems engineering forum by the Aerospace Corporation back in 2018. And it got me thinking about the whole question, what is it going to be like 10 years from now? Is SysML what we're going to be using? Well, we've changed languages constantly throughout the decades, as we'll show later. So what is it? What is that future of systems engineering? What are we doing? And if so, what are we missing? Is SysML, that SysML isn't enough? Is SysML enough? I don't know. And then, of course, we want to talk about the technology improvements that can make better systems engineering. So how can we do that? And then why do we have to wait 10 years? There's a lot of stuff today that's available that we can do and use and apply. So we don't have to wait for tomorrow when there's a lot going on today that we could do better. And so how can we predict the future? Well, it's very easy to predict the future when you've lived it so many times in the past. So let's study that past a little bit, the history. So there was a little history of systems engineering, and let me give credit to these. Many of these slides are from Dr. Peggy Browse's presentation at George Mason University. I was honored to help teach her class a couple semesters. So Anyway, so most people think that you can really trace it all the way back to the pyramids, thousands of years. If you think about these wonders of the world back then, in these BC times, I mean, my gosh, they had to be designed and built systemically. If you didn't, you would have really difficult time putting it together, particularly how they had to transport all the materials. And I mean, you think about the whole logistics of that aspect of things. And so those are part of that systems engineering thought process. So thinking as a system. Other people really say, well, really it began in the machine age when we started doing the Industrial Revolution. You need assembly lines. And that again required systems thinking. It was very clear that those needed that kind of thought process. A lot of people really trace it back to today's systems engineering. The way we think about it today is to the space age. And Ramo and Woolridge, who were the founders of Ramo Woolridge Company, but that became Thomson Ramo and Woolridge, which became TRW, which was bought by Northrop Grumman. so many of these things happen over time. Yet people go into different things. I actually worked at TRW, so I remember we had a lot of interesting names for it, but it was a great company at the time, and I was working there, and they had quite a bit of ability to support the Defense Department, particularly in a lot of what they did. So that was when, you know, okay, so now you're starting to think in terms of millions of parts, large numbers of contractors, I mean, a lot of work. So the system became a really big deal, and having to work the system meant really a system of systems even then. Today, wow, complexity has gone out of sight. You look at the amount of data we're talking about. I still remember when a gigabyte was a lot of data, okay? A lot of data. We were still thinking in terms of bytes and kilobytes. Well, now it's zettabytes, and that probably is not going to be enough for very long. So that's the 10 to the 21st bytes, in case you're wondering it. And there's a great chart here I picked up at a symposium done by Dr. Kurt Bourne at Booz Allen Hamilton, and he did a wonderful presentation on that, showing you the amount of data we collect from sensors on one commercial U.S. jet per year. I mean, it's stunning amount of data. So it's just something. So how can we deal with all this data? How can we work with it? So let's hold that for a second, that thought, and we'll get back to that in a minute. So again, let's talk about the languages. How are we supporting all that data? Okay, we want to show the data, we want to work with the information. How are we going to work with it? So back in the 60s, I mentioned flow charting. That was a pretty typical technique. We had templates for that. You draw your data flow diagrams and things like that. And of course, Jordan DeMarco data flow diagrams came in in the 70s, and we tried to apply that to systems engineering as well. Limited effort. I dabbled with using some early tools using that technique in the 80s. In the 80s, we had IDEF, state machine modeling, computer-aided systems engineering tools were talked about. Particularly one of the emerging ones that I particularly got familiar with was RDD100, which I thought was actually quite good. That actually came from the work done early in the 60s, late 60s, early 70s by TRW. So that was an offshoot of that work. That also became the predecessor in the logical sense to Core, Vitex Core tool. So that's where that came from. We certainly looked at that very heavily in as we were looking at developing Innoslate. And then in 1990s, enhanced flow block diagrams, that's the Core diagram, particularly that's their term, was one of the things they were developing. The object-oriented analysis and design was starting to emerge. We saw them come together and put together this thing called UML, Unified Modeling Language. Again, software. You notice this is all software, though, focused, right? All these techniques are being derived from software, including now SysML, which is a profile on UML. So they're coming from the software world, and the software paradigms are very different than the systems paradigms. One of the things that we've noticed is that systems engineering is actually closer to program management than it is to software engineering. So they're very different kinds of disciplines, and we need to recognize that aspect of it. So in the 2010s, we're still using SysML. It still seems to be pretty hot out there at the moment. But things like Lifecycle modeling language has emerged to help provide an ontology for the SysML. In fact, that was provided back in 2014 as from version 1.1 of LML. Provided an ontology that easily can be used to represent all the SysML diagrams. So again, the key is focusing at the systems level instead of at the diagram level. How can we work this as a system? And why do we always seem to be 10 years behind the software people? So what's missing? What do we need to do? So to understand what's missing, we need to say, well, what do we need to do, right? We need methods to capture and visualize tremendous amounts of information, right? The zettabyte kind of world is where we are, and we're heading into whatever's the next 10 to the third beyond that. The massive storage and retrieval of information, so that has to be dealt with. We need not only the technical part, but the programmatic part. You know, as I said, program management and systems engineering are very similar to each other. Both optimize cost, schedule, and performance and mitigate risk in those areas. One does it for the program, the other does it for the system, okay? So again, that's that commonality between the two. And that's recognized now. PMI and Innoslate put out a book about integrated program management and systems engineering a couple of years back now. Quite a good book. Take a look at that one if you get a chance. Anyway, so another thing we need is capability to move the data around easily between applications. I sat on the tools working group with Innoslate for almost 20 years, and the vendors kept saying, oh, we'll have a mechanism to move data seamlessly between tools. Still waiting. There are people, everybody has kind of their own way of doing that, but we kind of gave up. So when we built Innoslate. So another thing we need is a language that enables decomposition and abstraction, because that's fundamentally what we do. And we need a systems engineering language, not a software engineering language. Again, I tried to use those software approaches decades ago, ran into RDU 100. Finally, there was a systems engineering based approach that really seemed to be a good approach to the problem. And a language that's simple, so systems engineering can be done easily. And because remember, we have to communicate with everybody. So we're not just talking to the software developers. We're talking to every stakeholder in the system. And so you're going to get lots of people who have never even heard of object-oriented anything. So we need to have something that gets this all together. Now, you might say SysML does this, right? Well, what we found was, as we did some work, was that the interest in UML itself has peaked back in 2004. That was the earliest, actually, we know of, because this is the Google Trends, and so that's the best data we have. So it might have been better, might have been better or worse before that. We don't know what the run up to that curve was, but we know it's been on the downslope ever since. And I didn't realize it until I hired a couple programmers from one of the top 5 computer science schools in the US. And I asked them, well, what UML diagrams do you use? And they said, what's UML? That was my first clue. And then they, thought back a little bit and said, well, maybe we used a class diagram and maybe a sequence diagram. And that was about it. And they had that maybe in one course. So this is the problem. The software developers have moved on. They're using something called Agile, scaled Agile frameworks, things like that. But those Agile starts from functional requirements. So Agile software development is starting from functional requirements. Where do they get the functional requirements? Well, they get that from us as systems engineers. We're the ones who have to give them the functional requirements for the software they're developing. So, and then when we're testing it back, we're testing it against those functional and of course also the performance requirements that are needed as well for the overall system. So making sure that software works in conjunction with the overall system requirements, performance requirements as well. So what we found was that also SysML and UML really require experts to create and interpret. It's actually very confusing to most people. I personally think they've got the arrows backwards too. I look at the flow and it always confuses me. Frankly, I have to rethink about normal flow with the way they designed those diagrams. So what we need in systems engineering is a mechanism to be able to communicate with everyone. Okay, so if SysML doesn't do that, what do we do? Well, so and I guess it's worse than not being easy to understand. It's really lacking the programmatic pieces of information, risk, issues, decisions, schedule, cost, all the stuff that we need for that optimizing cost, schedule, and performance. If all you're worried about is performance, maybe SysML does most of the job, but again, it's not something that people will understand easily and can work with easily. And so that lack of ontology, by the way, is a big problem. And they know that, and that's being worked. There's an RFP out for developing an ontology. But we actually have one available, had one since 2014. It's called the Lifecycle Modeling Language. You can go to lifecyclemodeling.org and see it. It's an open standard, completely available to anybody. It's not proprietary to Spec Innovations or anybody else. The chairman of the steering committee for it is a Naval Postgraduate School professor. Okay, you know he can't be behind something that's proprietary. So now let's talk about the technology improvements. Now we've got kind of the language we're kind of working to. Let's talk about technology. So what can we do? So what are some of the emerging available technologies that were from the future? Well, cloud computing, right? Cloud computing is all the rage. Cloud computing was started back more than a decade ago. We got involved with it back in 2010. Our first version of Innoslate was on the cloud, 2012, when we first released Innoslate. So we've been doing cloud computing for 8 years. It's not new, it's already here. We've been using it. We use it today, everywhere. We're on private clouds, public clouds, classified clouds, you name the cloud, we can be on it. Artificial intelligence was another thing that people would tout a lot. Well, certainly NLP has a great, natural language processing has a great potential for what we do in systems engineering, because a lot of what we're doing is textually based, and understanding the language and working with the language and doing things with the language is something that can be very valuable. So that's something that's really, again, kind of off the shelf, available. There are all kinds of things for it. There are pre-trained machine learning algorithms as well that come from that. So again, we've applied that. Graph databases, again, they're already here. There's all kinds of ones out there. Each of the big vendors, Azure and AWS, have their own kind of graph database. Google, of course, is where we started. That's the graph database. So again, those are available. What we've been looking for is a good portable one that people have, that the community seems to be going towards, and Neo4j is sounding pretty good. But again, it's available today. You can apply it, use it, work with it. And of course, we hope optical computing's coming soon. So I suspect we'll have to re-architect again for both those two technologies. We actually migrated away from the Google Graph database because they kind of abandoned the government space, which is where our primary support is. So how can they help us? How can these technologies help us? Well, cloud computing, again, is a means to collaborate worldwide. Again, we take advantage of that. We have a customer who's working in here in the US, in England, and in India. And they all collaborate together and work together, and all very seamlessly across the world. So that's here. Artificial intelligence, we've applied NLP several places throughout our tool. So that's been a very helpful thing for that purpose. Again, the graph databases can give us the the storage capability, greater storage. So we're looking forward to moving back to that point at some point in time. And then optical computing. That, of course, once that's available, that will really speed up the computational. So again, like much higher fidelity modeling simulation. So we're always looking forward to these tools. So again, we don't have to wait 10 years for most of this. Okay, a lot of these technologies are here today. LML gives us that open standard. It's free for use. Any other vendor can pick it up and use it. We highly recommend they try. It's actually very valuable and useful and easy to use. It's also designed to be just an 80% solution. It's not an ontology that's complete, perhaps, for your domain-specific application. What we find that we most of the time do is add typing types, and which we've implemented using labels. So that's something that's, again, very easy to extend the schema and work with. But the key is it's a simple language that you can easily understand, you can easily use, and easily communicate to almost anybody with. I won't say everybody, of course, there's always somebody who won't get it, but they won't know what a loop is. Then you're in trouble. But most people in our businesses understand these basic logic constructs. So Innoslate, again, already uses cloud computing. We use NLP extensively through the tool, and we designed to scale. So it is designed to deal with the cloud kind of environments. And of course, other tools are beginning to realize the capabilities and are starting to migrate to the cloud, but most of them still have not re-architected for the cloud. And we found early on, we actually had started building a desktop tool, abandoned it because we realized you couldn't get the scalability you need and take advantage of cloud computing unless you architected for cloud computing. So we've done that. And so we like to say the future of systems engineering is here, because we are doing things well beyond what the 1990s technology that most people are using today is out there. So again, Innoslate is that part of that future because it gives a full ontology. We've actually extended the schema for V&V. We have implemented the SysML extensions that are in 1.1 of LML. We automated the traceability. We're going to show you all these things. We have automatic diagram and document creation from the data. Again, we're implementing concordance. We use extensively cloud computing technology and AI. The full taxonomy for LML, if you're not familiar with it, is extended to these. You can see the different classes and subclasses we have. We've added subclasses for like test case for action, but these give us a whole breadth of things. We can do cost, schedule, performance. We've got costs explicitly, time explicitly for schedule, and performance in many different ways, and particularly measures for which you capture metrics. We have other things, decisions, risks. Again, a full set of data we need been added to the tool. And again, you can extend it as you need to. If you want to subclass things, a number of different ways of doing that to make it better. So the key is that these are our nouns of our language. We have attributes on these classes, these ND classes. So those are their adjectives. For the rest of that, we need verbs. So the verbs are the relationships. Everything's connected to everything relationally. And we have multiple relationships sometimes between classes, even within the same class. So those are their use. But what we did was make them consistent. And the other thing we did was make sure that the consistency in the verb form of the relationship is the same whether you're coming or going, depending on which direction you're coming from. So that helps you track and see. So I see a characteristic specifies an action, and an action specified by a characteristic. So that makes good sense. Very simple. We did add orbital information because orbital was something that was always I always found that was a relationship that was missing. So that was one I think was fundamental particularly for us who work in the aerospace community. Now those relationships can have attributes on them. Okay, those become the adverbs for our language. So we have a very robust language that's very simple in the beginning in terms of the number of bins of information where I put things, But I can extend that with the use of either subclassing or with just simply adding typing to it that again, we've implemented through labels. But the real complexity comes here in all the relationships and having it all connected together. Now, one of the things is there's so many relationships, the tool has to help us manage that. And Innoslate does. It was designed to handle that very well. Automated traceability, again, we have using NLP for that to help us create relationships. We have a traceability assistant and also a suspect assistant that help us look at traceability and create these traceability matrices. Very easy to do. We don't do it fully automatic. I would call this more semi-automated because we don't want you to assume that the AI is going to do all the work for you. It's just not. That's not the reality. That's not the state of the technology. So you still have to do some thought, but it'll look at the matrix here, looks at the name, number, and description of the information between the two items to see if they should be fit together. And so again, you want to use that appropriately. You can do impact analysis using the spider diagram because we automatically create the inverse relationship for you. So when you create a relationship, the inverse relationship is already created. Now, that does have some impacts on scalability, but in general, we found that not to be much of a constraint. If you're doing proper job of abstraction and use of it, then you shouldn't have much of a problem doing it. And ease of use, different views. So actually from one view, we can create multiple different pieces of information. The actual tool, we like to say that there's two things. There's the data and then the rules for the view for whatever you're in. And so what it does is it looks at the database, puts the information in that view for you automatically in the right forms and format to be able to work with it. So that's how we generate the concordance. Again, all kinds of diagrams are available functionally, many different types, and we keep adding them as people come up with new ones that we have never done or used before. We're happy to add those. They're very easy to do for us. And then physical as well. Lots of different physical diagrams. We even came up with some things that people have never thought about, layer diagrams and things like that. Stuff you do in PowerPoint that you can easily create from this as well. Document generation, again, you can author all your documentation from the tool. You start with your project plan, test plans, anything you're trying to do at the early phases of the life cycle that you should be doing at the early phases of the life cycle. Building into your requirements documents. You can ingest documentation as well using the tool externally, using the schema at the import analyzer. AI, we also have applied AI here in the intelligence view. By the way, two places, yeah, another place we use AI here is in the quality score. So the quality score is a quality checker, and that basically will take and read the description field for the requirement and then score it against 6 out of 8 criteria that make up this score. And so that's again semi-automated for you. And then intelligence view is one of my favorites because it has 68 heuristics. That came from research done by Naval Postgraduate School and Stevens Institute of Technology and Dr. Kristen Giammarco's work. And so that gives us best practices. And so we have algorithms to look at the overall database and generate these issues for you to track and look at. And then we give you a fix button. So for example, if you have 2 gravitational parameters there and you say, well, they're really the same thing, I want them merged, you hit the fix button, there's a merge button. Hit merge, it'll automatically consolidate those 2 into a single entity. Works great. So Innoslate really, we think is at the cutting edge of systems engineering for the life cycle. You know, we have other capabilities people are asking for, model-based reviews. We've been doing those for, gosh, 4 or 5 years now. Workflow, there's fine-grained permissions with redaction, cross-project relationships, dashboards, all kinds of stuff. But we're not going to stop here. We have a major set of projects going on right now doing integration with design engineering tools. And so we're seeing that as part of the vision for digital engineering at DoD. So we're really moving that future forward as fast as we can. And so I hope you get a chance to see it. We're gonna do a quick little demo as we have a little bit of time, and then I will leave some time for questions. So send your questions in now. Okay, so let me refresh this because it will have probably timed out by now. Yep, I'm talking long enough. So we time out on the cloud fairly often. You can set that if you're putting it behind your own firewall, by the way. So, and again, so you can create your own private cloud, or you can use this on other clouds. And there are classified clouds that's available on as well. So this is the dashboard. The purpose of this is to provide information to the users. Just a quick look at some of the things. You just add the widgets that you want. If you're an owner of the project, you can save it in the project panel. There's wiki panel here where you can embed information, including live diagrams. These are 2 live diagrams in the tool. So if they're updated, they're automatically updated here for you. Here's a couple examples of bar charts, looking at status of things. This is part of our workflow, tracking of the requirements as well. In the center here is a table. Again, this table is something you set up. You set up the columns you want just by selecting the different attributes that you want to see, and have a custom query to have it to be the set of things you're looking for. This is just the top 10 on the dashboard. If you want to see the full set, you go to database view and you see all the different requirements associated with it. Over here on the right is an activity feed. This is where you can see who changed what when. Also, if you accidentally delete something, it shows up with a restore button, which is really nice, helpful. And then comments feed. So commenting here. So dashboarding is a key part of it. Feedback form, we really do take your comments to heart and apply them in the tool. So please feel free to give us your comments. Documentation wise, we think of documents as a model now. We have this view, every object. These are individual objects. So that's a requirement object. It has these attributes associated with it. Here's an example of the quality checker finding some problems with the verifiability of this one. It's missing one of the key parameters you should have for verification. You can see the relationships, what's associated with. You see this ST, and there's a V sometimes too. And those are the primary traceability relationships: satisfied by, traced to, verified by would be the V. So there you see those as well. Again, very easy to use, very easy to work with. This is all configurable. You can come into the settings and adjust the settings to different things you want to see. Oh, very quick, easy. There's even an acronym extractor, by the way. For those of you who have to build acronym lists, very helpful. All the reports in any view you're in are up here as well, available to you. So we go directly to native docx, Excel, PowerPoint, even on on the diagrams view output. Also, by the way, you can create templates here, create your own document templates. Lots of things with documents. Diagrams, lots of diagram types, just wide variety. We have, I believe, 25 and counting, and we have 2 charts views as well. So there's charting as well with the tool. Probably the most powerful diagram is our action diagram. You could see this as an activity diagram if you prefer in SysML. A little less understandable. But again, all the symbols are here. These things work. This is decomposable. So, and let's see. Yeah, go to the decomposition diagram for that one. For some reason, that's not clicking in there. And then, of course, you want to see that as an IDEF0. So there it is as an IDEF0. So it's all the same information, just seeing in different views, because it's just data, and I'm just applying different viewpoints with it. Probably the most unique thing about Innoslate, though, is that and LML is the idea that instead of having a symbol for our decision points, we actually use an action, special case of the action for that. That makes it allocatable, so you can determine who or what does it, and that's very helpful. Also, built-in discrete event Monte Carlo simulation. Very fast, very rapid uses of it. The discrete event. There's the whole model in 3 dimensions. So you can look at it, you can execute it. Highly recommend speeding it up. Again, we're tracking cost here, got resource usage, people, firefighting team here is people being used. So builds up very quickly, building up a timeline in a Gantt chart format. We use this also for project planning, so you can export the project, the Gantt chart. Very useful. And let me hit Test Center. So Test Center is here where we're capturing our test cases, expected result, actual result, status roll-up. You can track back to things, a couple of different things you can do since this is a subclass of action. Great. You can use the action diagram for it, so you can model your test processes early. So this is where we recommend starting early with your test development in Lifecycle, which is, of course, what the V is telling us we're supposed to be doing. Again, you can simulate it, you can get cost on it. It really helps you do everything you're trying to do. The traceability matrix, just show you that really quickly. Let's do a query. And all my verification relationships start with VR. Verify. So this is showing me how I've connected them together. If I want to check that, I can run the traceability assist, and I can also run the suspect assist. Showing the opposite. So it's showing you the different things. And it's just looking at name, number, description, seeing if that's a high probability. So the darker the green, the higher the probability they should be. Okay, so I wanted to leave some time for questions. There's just lots of other features of the tool. So let's open it up for questions. Sarah, do you have any questions?
Oh, yeah, thanks, Dr. Dan. We've already received a few questions. If you haven't done so, please send your questions through the panel on the right. Please feel free to ask as many questions as you have, and Dr. Dan will answer as many as questions he can before our time is up. So the first question was asked pretty early on in the webinar. Is the source a multiple repository using a single user interface?
No, it's one database backend. It's we actually work off a Postgres or SQL server are the 2 primary databases that we work with. And so we think it's helpful, but at the same time, you can have multiple projects and then have cross-project relationships. So you can separate the information as you need to as well. So you get kind of best of both worlds with that.
Thank you. How do you create multiple instances of a block or asset in Innoslate in order to show how they connect in an IBD or physical I/O diagram? For instance, you have an existing block called display in an asset diagram and want to show 4 different displays and their inputs in an I/O or IBD. How do you show multiplicity?
So multiplicity is used, we use cloning for that purpose, and that gives us multiple objects, and then those are used in the simulator to see that. If you want to see them physically in the diagram, we recommend those are actually 4 different physical displays. They might be the same parent class of some kind or parent type, but they are fundamentally 4 different displays. So you would show 4 different ones.
Thank you. How do you auto-generate SysML requirements diagrams from the requirements view?
Okay, so if I go to a requirements document, I would come here and open. I guess I've got to select a requirement, sorry. And then open a requirements diagram. There it is. So, and I didn't draw that, it just pulled the information from different places and shows the different things and how they're connected together. We got satisfied by, so you're seeing all the other relationships as well. So you just open it. if you've done all the other work, it's right there.
Do you have a generalization relationship, i.e. if you have a generic GPS asset and want to show multiple types of GPS off of that block, what relationship in LML would you use to depict that?
So again, what we do is we use, we would take a, okay, so a couple of different ways of doing that. One is create a parent class of the information, and then you could have subclassing off that if you want. So that's one way perhaps to do that. But to have the actual separate instances of an object, again, there would have to be separate objects because there are instances of an object, right?
Can 2 or more engineers work on the same project simultaneously?
Absolutely. And in fact, you can have as many people on it as you want to. We share with multiple people, and I could have all of them on it at the same time. And you'll see indicators when they're on with you. There's also a chat window, and then you see online users. Here's a couple people who are looking at different parts of the tool, obviously. And then you can group chat with them as you need to. Just close it that way.
Could we feed external raw data or certain format data to the model? For example, model handling patients and using the feed system bring data for patient increase, say for COVID-19 or any other medical ventilators per week. Obviously,
sure.
Yeah.
Go ahead. So let me just show you that real quickly. So in the tool, there is the ability to add scripts. So the scripts, we generate a lot of scripts for you, okay? So this is an auto-generated script, but you can put in your own scripts and use the APIs to do a live feed. And we have done that before. In fact, somebody did it with temperature. So they'd go out and pick up what's the latest temperature and use that to make a decision. So yes.
I am asking for more examples than FireStat. Do you have any more?
We have lots of other examples. Let's see. Let me go find a couple good ones. Let me go get my DODAF one. That's a good one. So this is my DODAF demo, and so we actually have in here an OV1, things like that. Here's some models. I think I'm just working on these models some. I think they broke my models, so I have to see it. But here's a defending against a missile attack. So that detects a launch, missile detection, updates the position, looks at the launch location, tasking the defense asset, and attacking the missile. So, and again, that should, let's see if that runs. Because some of these have been broken over time. And then so you pick the number of iterations, and so let's just do one. So yeah, and we have a number of other models that are available. If you want to, one of the best places to see some other models as well, highly recommend going to the organizational dashboard and start the guided tour. Guided tour gives you 3 different examples that are pretty good. You can look at and understand maybe its utility in other domains. Okay.
Is the FireSat example available to go through in open source?
Right here. That's the FireSat example. So you can go through and work with that. And if you need something more, we can send you other ones. There are other people who've done a lot of work in FireSat, so they may be available. We can maybe get to those as well.
Someone defined 4 pillars of SysML. What would you say are the pillars of Innoslate?
I would say ontology and diagramming, and so visualization. So we don't not a big pillar fan. So it's more about what's the data I need to capture and how do I want to see it.
How does UML fit into LML?
So UML is just a diagram. So for example, let me get to, let's just get an example of, let's see. We've got use case diagrams. Here's a use case. I believe that's a UML diagram. We have class diagrams as well. Back to, let's see if I got a class someplace. Nope, I don't have one in this one, sorry. But we have class diagrams as well. We have a number of different diagrams. By the way, let me just go back to here. If you didn't notice, this is where you can get it to PowerPoint. So what it does is put a document image, the name, number, description field, and then put that into a file for you. So that's how we convert to PowerPoint, by the way. So I figured I'd say that while it's here. Okay.
What is LML to Innoslate in terms of relationship?
So LML is the underlying ontology we use in Innoslate. So it gives us our database schema, basically. It's probably the simplest way to think of it.
Innoslate can Innoslate be used in real time?
Yes. Yeah. Again, we actually can use the. In fact, you can run the simulator in real time when you do discrete event. Show you really quickly here. When you're doing the settings, if you want to have speed be real time, there it is. So you can go slower in real time. So if you have a smaller, shorter term process that you're looking at, you can look at that as well.
How well do people transition from using SysML purely to using the LML ontology in your tool?
We found it to be pretty quick and easy because, again, they can start building an activity diagram the way they're used to doing it, pretty much. And then all they do is to move to LML is to select the action diagram, and there I am. So it's pretty straightforward.
Is Innoslate available to university students? Please explain.
Oh, yes. In fact, it's free. Sign up with your .edu and you're automatically upgrade to the academic version. We also make it available for at the organizational level for different universities. We're actually in over 200 universities around the world are using the tool today.
Can you recommend a university to provide a reference?
So gosh, MIT, Naval Postgraduate School, we're at the Air Force Academy, West Point, it's used at, let's see, I believe they're using it, oh gosh, several other places. They're not all coming to me quickly. Purdue, I think. Just lots. We probably can give you a specific, if you want to know somebody specifically. George Mason, of course, is using it as well. So.
Thank you. I didn't follow how LML lets you have the auto generation. What was that word again you used that MBSE needed? Can you explain that a little more?
Yeah, concordance. So concordance is that thing about moving from one diagram type to another with the same data. So I'm not drawing these other diagrams. So from here, when I select activity diagram, it just reads the database, looks at the same data, and portrays it in this format, because that's the format that's the standard for the activity diagram. So those are the things that it's doing automatically. So that's concordance. So if I change this object here, let's just change it. I'm going to say transmit update to ground. Okay, right? So I save that, and now I come back to that equivalent diagram that now says transmit update to ground. That make sense? That's concordance.
Next question is, what features are in the plans to come out this year?
Okay. So our next release, we're in version 4.3.1. And by the way, the version numbering that's the architecture version number is 4. So we've re-architected the tool 3 times since 2012. That's the first thing. So the next major point release that's coming out is 4.4. That's hopefully before the end of the year. We are focusing heavily on integration with the design engineering tools. There are at least 3 we're looking at right now that look like they're pretty close to being able to be done. MATLAB, Simulink is one tool. You could get to Simulink through MATLAB. Then also GitHub, which also may get us to Jira as well. And then we're looking at Systems Toolkit, STK.
Perhaps with simulator running real time, one could see the passenger throughput through a subway usage. If the feed of tickets scanned into the subway is supplied through the live data feed system.
Mm-hmm. Yeah. Again, as long as it's a web-enabled kind of feed or some kind of feed that we get through the web, it's certainly very doable.
All right, that concludes the question and answer portion of our webinar. We would like to thank you again for joining us for today's webinar. Make sure to join us next time for our next webinar, Verification and Validation Using Innoslate, on September 2nd at 2 p.m. Eastern Standard Time. As always, we will send out the recording and slide deck to everyone that attended today. We would also like to make a quick announcement for the Model-Based Systems Engineering Conference that Spec Innovations will be sponsoring virtually on February 22nd through the 24th, 2021. MBSE Con is a conference dedicated to the systems engineer and learning more about MBSE, the functions of MBSE, and how the Lifecycle modeling language assists model-based systems engineering. Please keep on the lookout for more updates on MBSE Con as we approach the date. For more resources, we encourage you to visit our website and our blog, as well as connect with us on social media through the Innoslate user group or through Twitter using the handle @Innoslate. That concludes today's presentation. Thank you again for your attendance, and we hope to see you again at our next webinar. Please enjoy the rest of your day.